We're going to move right into our next presentation, and remember to keep questions coming in the chat for the Q&A session. So next up is EMMPOL, which is the Euro-Moon-Mars Poland Moon Analog Mission, and that will be given by Perrier et al.
Hello everyone, can you hear me?
Yes, I can. Yes, I can.
Thank you. So I will start by saying, oh wow, I feel like a droplet in this ocean of knowledge and experience. I'm from France. You can see IPSA Aerospace Engineering School, and thanks to a collaboration with the International Lunar Exploration Working Group, Euro-Moon-Mars, and the Analog Training Center, we had a short, but very short, a window of shot during the pandemics, and we had our first moon analog mission. So next slide, please. This is the first EMMPOL mission that took place 16th to 22nd of October. 3 of my students, Theo, Emma, and Michael, together with myself, were joined by Christian, who's a Polish master student. Next slide, please. EMMPOL 2 mission, 23rd to 29th of October, composed by three other students of mine, Julian, Conta, and Hugo. We're joined by Amanda from Canada and Roberto from Italy. So actually, we're a small group. We're remotely supported by other students, and what's very particular in our organization, next slide, please, is that EMMPOL 1 mission was had as MCC crew the EMMPOL 2 mission, and 1 week later, EMMPOL 1 mission become the MCC of EMMPOL 2 mission. We organized very simply with a flight director that had the general view of the mission. Analog astronauts were producing data, transmitting to Capcom and then to MCC crew, and we were actually inside the MCC, scientists, engineers, and medical crew, and we were taking data, each one of from the messages, everything that we needed to process as info. Next slide, please. We actually had science inside the moon base because we weren't able to do EVAs, but we went to a model that we thought would be the Artemis mission once a base will be on the surface of the moon. We did aquaponic and hydroponic system, life support system, recycling, sample returning system, and water budget. Next slide, please. I'm going to do this fast. When we got in the base, what we found as aquaponic system was what we have on the left of your screen, a very simple structure. And after 2 weeks of working hard with MCC, that means that the communication that I'm talking about later a little bit was very tight, and we had, after 2 weeks, a system that was complete with 3D printed parts, and we got live on the moon base after 2 weeks. Next slide, please. But also we asked for a simulation of power failure, and as you see here, we tried to save plants through a non-circulating hydroponic system. We improvised, of course. There are parts that were 3D printed, that were designed by the MCC crew, and we tested different pH water and different types of soil, going through soil that was like regolith type, and we controlled parameters with no electrical consumption. So we saved plants for the analog astronauts, for our future astronauts, hopefully. Next slide, please. Our vice commander was dealing with algae-based bioreactor that helped us lower the level of CO2 inside the base. So you're seeing here different, so this is on a daily basis, we had twice the reports of CO2 levels inside the base. You must understand that during our simulation, our systems of having the information about our temperature and CO2 level inside the base was down. So we are completely depending on MCC and our backroom. So communication, once again, was very important. We had an alarm because the CO2 was too high, a situation that could occur during an EVA and during while being inside the pressurized suit outside. So it was really dangerous, and we had to act fast because we were 5 inside a small moon base with 4 rooms, yeah, but CO2 is dangerous, so MCC was very important at that time. Next slide, please. Talking about soil and waste, like it's nowadays very important to recycle. We used, thanks to the collaboration with environmental friendly company, gloves, wet towels, and garbage bags that were made of plastic, decomposable plastic. My student here in the images put it inside 2 jars with 2 different types of soil. Wet towels and gloves were checked. pH and temperature and humidity were checked by the MCC. And we saw that 2 weeks it's too short for seeing any evolution at all. So we would like to continue next time and try this outside the base too. Next slide, please. Sample returning was important for us, and mainly one of my first year students, 2 of my first year students proposed this 3D printable launcher. The plans were done on the software in the MCC and transmitted to the base. They 3D printed the parts and then put it together. They calculate an average of 200 to 500 grams of scientific sample to be sent to orbit or to Earth. Next slide, please. So we did science with water too. Next slide. I'm going out of time. So water budget was very important for us to monitor. So as you see here, we monitor drinking water and urine, but also shower water. As you see for the tables, if you can see, we stick to the plan and only had 1 shower in a week. So it's very important. We stand for that. We're very proud of that. Next slide, please. During MCC, the well-being of in the MCC, the well-being of our astronauts was very important. So here you have just a part of the parameters we're checking from the back room. Next slide, please. Okay, so daily schedule. We talked about this. So everything I'm saying here, we already heard it yesterday, and today's schedule is very important. And we're proud that our schedule, we're really taking into account astronauts' demands. I remember being into the base and doing petri dishes and telling myself, how did they put only 1 hour on my schedule, because it's too long to take as much samples as they asked. And they just regulate that, and for the next day I had 2 hours, and it was cool for that. But next slide, please. What we understood and what we saw, even though we prepared the mission for months together as a team, like we're 20 people remotely preparing it because it was a pandemic, communication was one thing that was unexpected problem. We went to Poland and we lost signal for the communication. We had blackout. We had half a day with no communication, and the team had to handle that scientifically. Like, how do you handle your scientific operation when you have no communication with MCC? We handled it because we had multiple competencies inside the base. So 2 different communication channel in different locations, that's already known with Curiosity, so it's already known. But what's very different is that we went to Poland and we really felt like astronauts going to the moon. It was completely different. What we found was completely different than what we trained to. So preparing missions together is very like a key for us, like not for everything, but scientifically speaking, being able to adapt the science protocol, the daily schedule, know each other and each other roles, and mainly like structuring, point of view of structure, just being in the same room or same location seems important for us. Thank you for your attention.
Thank you very much.